Hey everyone, so we've got another teardown to do today. What we're going to look at is an LTO-3 tape drive. An LTO drive is used as tape storage backup for computers, developed in the late 1990s. So yeah, we're going to have a look at that. But first, I'm going to show you the device that it came out of, because I've just picked this up. It was on eBay, broken. I've just fixed it up, and I'm going to take the drive out, and I'm going to tear down the drive, but the actual unit here is going to go off to a friend of mine who wants to put an LTO-5 tape drive in it and convert it. So this is a Dell TL-2000 tape library. It's a 19-inch rack unit which can take 1 or 2 LTO tape drives, and can also store up to 24 LTO tapes. And there's a robot mechanism which takes the tapes and pops them into the drive so you can access them over the network. As I said, this takes up to 24 of these LTO tapes, and it's a completely automated system, so you don't have to keep going down to the server room and swapping tapes in and out. You can just possibly have 1 or 2 of the cartridges and you just swap those out weekly or something, so it just makes it a little bit easier. So I think this unit dates from about 2008, I'm not entirely sure. The LTO-3 drive can store up to 400 gigabytes on a single tape. They do have compression as well, so they can theoretically go to 800, but I don't suppose you ever really get that. So you can have 400 gigabytes per tape. And there's 24 tapes, so that gives this unit a total capacity of 9.6 terabytes. Now, obviously, when this is upgraded, it will be a whole lot more. If you upgraded this to an LTO-7 drive, which is the largest available at the moment, you'd get 24 tapes, each storing 6 terabytes each, so that would be 144 terabytes, which is quite impressive, really. So anyway, back to the case in point. I'm going to just quickly run through this because it's kind of interesting on the inside, and then we'll get cracking on the tape drive. So if I just take the lid off this, so you can see here we've got these are 2 tape cassettes. I've got 1 on each side. We have a robot mechanism for loading and unloading the tapes here in the centre. Just at the back here we've got a small controller board, the actual tape drive in the middle, and a power supply. There are a few user controls on the front. I won't bother trying to show you them because they're not particularly interesting. So on the tape magazines, you can these would release and slide out of the rack unit that way, and then these store this is a 12 tape unit, and there's of course another one on the other side. So all these tapes would be stored in there like that. They all have barcodes on, and there's barcodes in the back as well. The robot mechanism actually has a barcode reader, so it can identify all the tapes, and it knows where each of the tapes are, because it does get a bit complicated when it comes to managing backups and things like that. So everything's barcoded, so you can keep track of it. Now, one thing that I did find interesting with this is these little clear plastic sections in each of the tape cartridge. These are actually light pipes, as far as I can tell. There's no LEDs or anything in this part. The LEDs are actually in the drive head, and as it moves, I think an infrared LED shines through these little ports, and it gets a reflection back. So it uses these to find the exact centre of the actual tape slot. I think they've done this for size reasons. I wondered why they just didn't have a barcode or something that it could read, but maybe they wanted to keep everything as slim as possible, so they've gone for this optical solution, which is kind of neat. So when I picked this up, it was actually described as having a robot fault. Now when I took the lid off, it was a bit of a mess in here. There was tapes all over the place, and it obviously been turned on with all the tapes just strewn, so this tried to move, it's jammed up. This drive belt here was out of place. It also looks like it's been dropped as well. There's some damaged plastics. Some of the plastics around here have been slightly damaged. Now I've fixed those up, and I have fixed up the robot head as well, which had some very, very minor damage on one of the gears. So that I've fixed up. So it does all appear to be working fine. So this should be ready to go and be reused. Right, I can actually show you this running, which is kind of interesting, because it's kind of nice seeing electromechanical devices whirring away and doing their thing, so it's quite cool. So I'm just going to power this on. It's a bit noisy, because as anybody who's been in a server room knows, it's always noisy as hell. So I'm just going to turn this on. You probably won't be able to hear too much, but the fan noise does quieten down after it's finished booting up. Now this does take a little bit of time to boot up, so I'll see you in a moment. Now what it's doing here is just going through and cataloguing all the tapes, so it's reading the barcodes that would be on the tape. I believe the clicking seems to be a focus mechanism, so it's actually adjusting the focus. Looks like it's picked up that black tape is actually a cleaning tape, so I think what it's going to do is load that into the drive and do a cleaning cycle on the tape. Right, well that's enough of that. Let's take the drive out and take it to pieces. So I need to just take the drive mechanism off this this drive sled. Right, we've got the drive extracted out of the sled, which plugs into the tape library, and obviously it's just a standard form factor, you know, 5¼ inch and half height. The tape goes in the front here. There's no bezel on this because they often omit that on the drives that are intended to be used in embedded applications, because you just don't need a bezel on it. But you can see the little clip marks, so the plastic, you could clip one on if you wanted to. Around the back we've got a small little fan, and we've got the SAS interface, that's serial attached SCSI. A couple of odd little connectors. There was one of these connectors which is known as an LDI interface, which is a library device interface, which is allows the tape library to actually talk to the drive without going through the SAS interface. Right, so under here we've got quite clearly two motors there. I'll explain why we have two of those in just a second. So let's whip the top off. Bit dusty in there, but according to the menus on the library, it had actually been turned on for about 41,000 hours, so it's hardly surprising there's a bit of dust in here. So here we can see the main mechanism. We've got what looks like a load and unload mechanics here, and this is obviously all the tape transport mechanism. Now if I start putting a tape in, I don't have this powered up yet, so we can just have a look to see what how it detects the tape. We can see just down in here we've got a small optical sensor there, so when you push the tape in, it moves this piece of plastic and breaks that beam there, so then it'll detect that there is actually a tape being inserted, and then we'll just start drawing the tape inside. Right, I'm just going to put a tape in, but unfortunately at the moment it doesn't actually want to load this in. The display on the front is showing an error, so I wonder whether it is expecting to be plugged into the library, so it won't seem to do anything. But I think if I'm putting this into service mode, I should be able to get it to load the tape. I'm just pushing the button on the front here just to put it, that's gone into service mode now, so let's try popping this in again. Okay, what that has done is loaded the tape, and it's extracted the tape out of the actual tape cassette itself, and it looked like it pulled it all the way around here, and would have attached it to the take-up spool just in here, and by the sounds of it, it wound off a fair amount of tape. Obviously there's going to be quite a bit of lead in tape before you get to the actual good bit of tape, because the beginning of the tape is always going to get slightly damaged and distorted. Well, I'm not quite sure what it's doing, but I have noticed that the tape head, which is just here, you can actually see that moving slightly. You can see it tracking up and down very slightly, just here, and you can see the bottom of the head just down in here as well. And it should bring the tape now around the head. And you can just see the head moving up and down very slightly. Okay, if we sort of have a look at this in a little bit more closer detail, obviously we've got two motor drives here. We've got this one here for the take-up spool, and this one is for the tape spool. So as the tape is on here, the tape needs to be wound off and then wound onto this. So there's actually going to be quite an accurate speed control on these two motors to make sure they both run at the same speed. Otherwise you'll end up with slack tape, or you'll end up stretching the tape. So that's kind of interesting. You can just see the take-up spool just inside there. As I said, there's the head is just under there. We've got some nice machined rollers and a whole load of cogs and mechanisms there to take the tape in and out. We can't really see too much more just yet. There's a motor over here on this corner, which looks like it drives all of these. Wow, that's quite a number of stages on there. 1, 2, 3, 4, 5, 6, 7, 8. So there's a fair bit of reduction on that. And actually there is another small motor just on the corner here. And it looks like there's one down in there as well. So yeah, there are a few motors on this. A plastic protector. Well, there's not. There's a few devices on this side, but whoo, yeah, you can clearly see there's a big footprint for something underneath there. There's some parts here. So these are all buried on the other side, I suspect. Some fairly big high-density connectors, it looks like. Some other pass-through connectors onto the other side of the board. Okay, I've released all the flat flex cables. There's quite a few actually. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 of them, so it's quite a lot. It also looks like that the board isn't actually screwed down. It's just literally held in with the flat flexes and the metal plate that was on it. Right, here's the controller board. I'm not going to go into a huge amount of detail on this because it's a little bit beyond me, but yeah, there's some fairly large devices. There's going to be motor controllers and stepper motor drivers and all sorts of stuff. So on this side we've got some large BGA devices. These are all big name brands. We got IBM, LSI, NXP, IBM again. We've got quite a lot of these inductors around here, so there's going to be a whole load of local voltage regulation going on. These look like these possibly little power supply circuits here. Looks like we've got an optical sensor just there mounted actually on the board itself. Blah blah blah. Yeah, I'm not going to go into a lot of detail with this. It is just a controller board after all, but yeah, there's some pretty nice large BGA devices on there. That's an IBM one with a big heat spreader. Right, let's have a look a bit more at the mechanics. We've got all these flat flexes running over to various sensors and stuff. We've got the two main motor drives with quite a number of connections. Well, actually, they're not. There's not a huge amount of connection on there. It looks like it, but if I zoom in, you can see there's actually quite a number of connections on there, but most of them are just paralleled into these three main tracks. So that's for power, so you can get more power current down them, because I would imagine these are probably going to draw a fair bit of current. So they've just taken the individual pins and then just turned them into large traces. And at the front here we've got a little flat flex with some 4 LEDs. Those are status indicators on if you'd have a front panel installed. Those will just be there. And that small tactile switch is the eject button. This flex here looks to be runs up to this PCB, which is there's a circular trace on here, so I think that's the RFID tag reader that reads the tag inside the tapes. Motor connection. We've got these sensors over here. These are obviously the connections that run to the head. We've got 80 pins on that one and 80 pins on that one, so that's 160 pins running to the head. And if that's the head, then I would imagine that is the head positioning servo. There's obviously some sensors as well coming up on the same flat flex. Little plastic bits and bobs. That is that's a different plastic to these bits, and it has the feel of being a different material. It looks like this wheel here actually runs on this, so this is probably some plastic that's designed to have things rubbing against it so it doesn't wear. Got this little mechanism out here which basically allows this to, wow, what a lovely articulated little thing. So I think there's some very small little brushes on there, and they're black. I wonder whether they might be little carbon brushes, maybe some kind of static reduction to stop static build-up on the tape. I couldn't see that being actually used for anything, or any kind of cleaning or anything like that. I think that's maybe some kind of static control. This looks like it's the claw which grabs the end of the tape from the tape spool and then drags it round, probably passes it to something in here. Guessing there's going to be some kind of latch mechanism on here. Yeah, there's probably something down in there that it shoves it into. And we've got a couple of little optical sensors mounted on the this top of this plate. Interestingly, none of these little cogs and gears have any ball races or anything, so they just run against these machine posts. So these plastics will be designed to be effectively self-lubricating, if you want to put it like that, so they don't need any lubrication. So here we've got the main pickup spool. The end of the tape is just in there, so I think this would move around and probably capture that. I'm not quite sure how it would do that. Grab it and then pull it, and then this would then, I'm not quite sure how that would have got around there. Maybe I've missed something. But it would grab this and feed the end of the tape round here, continuing to work round, and then this would then line up, and then that would then drag the tape inside here. That would lock into place, and then that would stay locked in the centre of the spool while this can take round, allowing the claw to sort of stay in place. This can continue to spin. Oh, a bit difficult really. You get the idea. Little plastic piece, or we're actually starting to get some plastic identifiers on here. So that's PC plus GF50, so that's polycarbonate with, that's probably, what, 50% fiberglass? Yeah, it's definitely got quite a colour to it. That's going to be tough stuff. Tape guides. 3 of those on sprung-loaded mounts. Lovely machined piece of steel there, with probably some quite high quality bearings in there, I would imagine. And on this spool, which is almost identical, with the only change that there is some small ridges machined into the surface of the spool. This is there to reduce the air bearing effect between the tape and the spool, increases the friction, and that allows this spool to reduce high frequency fluttering of the tape before it runs over the read and write head. Wow, listen to the sound of that. It sounds like metal, but it's not, it's plastic. We've got PPS plus GFM65. So, not quite sure what that would be. The GF will be glass fibre. PPS, let's see what that is. And that is quite an advanced plastic actually. Polyphenylene sulfide. Polyphenylene sulfide plus fiberglass. But yeah, as you can, it's got sounds metallic. Wow, I bet that wouldn't have been cheap to make. So there is the actual tape head itself. I bet a lot of the cost of buying one of these LTO drives goes into that little bit just there. It actually looks like this actually has another degree of movement that I hadn't noticed before. You can actually move it that way, and this stepper motor drives it in a vertical position. So the stepper motor seems to do that way, but there is actually also, it's able to move this way as well. I didn't notice what thing there actually adjusted that. There's really quite a smooth operation on that. Oh yeah, there's why. This is why you pay your money. There's 2 small ball bearings just there to allow this to move backwards and forwards nice and smoothly. You know, although these would have been built to a price, but they certainly didn't skimp on it. They certainly expected people to pay the money. Optical sensors there. Nope. Tracking the position of the tape loading mechanism. You can see how when the tape goes in and gets drawn in, it actually, when it gets to the end position, it drops the tape onto the drive wheel. Yeah, there's more bearings here. Nice piece of mechanical engineering. Well, doesn't sound very healthy, but I wonder whether something I've taken off might have disappeared up inside. Looks like that is a permanent magnet motor. But yeah, there's something that got stuck up inside there. I've got a rating on there, 12 volt, 2.5 amps. So yeah, I thought they would draw quite a bit of current. Yeah, they are 30 watt motors. Yep, nothing more to see on this now. There's just the odd little optical sensor. Let's take out the RFID reader. Yeah, not much to see on that. It's just a trace on a PCB. Right, let's have a quick look inside one of the tapes. Go. We've got the little door, the nice, very, very fine spring on that. One big spool of tape. And the end of the tape with its pin on the end, which that little claw grabbed. That's the locking mechanism to stop the tape drive spinning around when you're not using it. Spring, the thingy-mabob. And we have the RFID tag. It's quite cool. You can actually see the dye in it. It's not they've not used black goop. And on an LTO-3 tape we have it's 680 meters of tape. So I'm not going to pull this off. Make far too much of a mess. Right, I think that's the end of that. You can guess that this isn't going back together. So it's a nice big pile of bits there. I hope you found that one interesting. Yeah, it was kind of interesting. I kind of enjoyed that one. It's been a long time since I've looked inside a tape drive before, especially one of these new modern ones. Or, well, fairly modern as this one is. Alright, thanks for watching everybody. If you liked it, give me a thumbs up. If you're not subscribed, hit the subscribe button, and I will see you on the next video. Catch you later.